Hello everyone, welcome to my shop. I'm Robin. Today we're going to cover the guarding that I have put on my HLVH, and it has protected this machine since I've had it roughly 20 years. And I'm going to cover how this is put on and some of the details and a few glimpses of some of the other machines that I have some guarding on, and we'll go from there. Some of you may appreciate my new first attempt at glare control by cropping. So you notice there's no problems here today as there were on the last video. So let me know how you like the new glare control. Here's an example of doing the guarding on a new machine. I spent a couple days doing guarding on the Tormach slant bed that I purchased before I even started, just knowing that this will make a machine last immensely longer. I won't go into all the details of how this is attached, but very simple, just simple cold rolled strips, drilled, tapped, glued, whatever, to various things. I'll cover this in more detail in another video, but the principle here is protect the machine. Think about controlling where the chips lay, where they end up, how easy it is to clean, and do it up front. Spend the time to make the machine right from the beginning, and it will pay you back in the not needing future maintenance. This is my HLVH, and just wanted to show some of the guarding that I have on here that makes this thing basically last forever. The reason I'm doing this now is because I need to replace this tattered and holey. Got to poke the hole in there, and as soon as you get a hole in it at all, then it's shot. Got to get changed immediately. But this is just from chips and things getting whipped around. So I have to take this, the rest of my guarding apart in order to replace this. And so I'm going to show that procedure and also show some of the construction details of the guarding that I put on here. This is, I think, nominally 1/32 neoprene diaphragm material. Has woven fabric in it. And the importance of that is that it does not grow when oils and things get to it and start to decompose the neoprene. That still happens, but it doesn't structurally change its shape because the fabric maintains the shape. So real nice stuff, real thin. It actually measures about 19 or 20 thousandths thick. So I have sheets here. I cut multiples while I'm cutting them so that I have replacements ready to go. They last quite a while, probably over a year at a shot. These are the skinny pieces on the side here that actually, excuse my hand here, these are the pieces that go down this side of the cross slide, and then the other two are the same length that go on either end, on this end and the tail end. I have my camera sitting on the bed right here, but there's one on the tail end here that can go between the tailstock. This cover is just a piece of 16 gauge stainless steel that was formed with the drip lip. Comes up, has clearance. The cross slide scale is in this gully here on the side, and it goes up on the top and is actually inlaid into the top of the cross slide. I'll show you that on the top. And then overhangs far enough to extend over to be able to attach the flap. This cover is held on with, not held on, but sealed with gasket maker stuff, gray or black, same thing, but really good stuff. This stuff is holds up to the synthetic coolants and everything. So you're going to see it's going to take a little effort to actually get this thing broken loose, because this stuff is very, very tenacious, and I don't want to bend up my cover. So I'm just gently putting some pressure on here and giving it time to pop like that. And over here on the sides I can get underneath. But yeah, this stuff really holds, and you don't want to pop things loose and bend up the sheet metal. So I'm just going to gently oops, got one screw left in there. That's a good way to bend things. The screws are just icing on the cake there to there So there's what we're looking at. This was precisely milled for the cutouts. This is thinned out to be able to go over the dial, and then the whole cross slide was milled correspondingly with a lip down the thickness of the 16 gauge material, drilled and tapped with 440 holes. In this case I used, and countersunk so that the flathead would actually bear on the sheet metal and not bear on the hole here. And so that's what it looks like under there. This is why the cover had to be removed, just to replace this, because this is actually up underneath. So I have 4 flathead screws holding the clamp bar on there to protect that. This is my X-axis mini scale and head mounted, so very solid mounting. It's also an opportunity to talk about Abi errors and placement of digital scales on a machine. This is something where people often put things on for convenience or the easiest mounting place or rather than considering the best accuracy location and making provisions to make that situation work. Abi errors are caused by curvature in a way movement, and if there's examples, you can Google Abi error and you'll see examples. The example of spokes on a wheel. If you have your digital scale mounted at the hub, and then you look at the motion being a huge curvature, you can see that the motion read by the scale and the motion read by the surface where you're working can be 2 different things. I know it's a poor description, but I'll cover those Abi errors in more detail. But in this case, having the scale right where you want it to be, in this case, right under the cutting tool. So my cutting tool, when it's on here, these cutting tools 99% of the time are directly over the scale, which means that even if there is curvature, I'm measuring right at this place. If you put it on the back side here, now if there's curvature, whatever that curvature is, what you're reading back here and what the tool are doing can be 2 different things. And then you put a boring bar out here, and now it's exaggerated even further. So this curvature like this, as the saddle or the cross slide does this in an exaggerated form, with measuring back here gives you more travel out here than the scale's actually reading. So that's why it's important. Now this, typically people would say, well, that's an insane place to put it. Chuck's right there, tools there, parts fall off. Well, that's why you say don't compromise. Spend the day it takes to make a guard like this and put it on there, and you'll be rewarded with no problems. Never had a single issue with this scale in 20 some years. So yeah, it's just worth the effort. Same way is my Z scale is mounted down here. It's mounted right here on the bed. Okay, difficult place. No machine surfaces. You have to do a lot of creative stuff to get the mounting spar mounted properly and aligned. The mounting system to get the head aligned on here is all immensely more difficult, but pays in the long run. It's protected, doesn't get on the back. We don't have to worry about other attachments not being able to put on. And again, it's directly under the work zone. Your general overall area of where you're working is right here. That's where the Z scale is, so Abi errors are minimized. Back here, you got a long distance, quite a distance away from where the scale is and where you're working. You're gonna introduce Abi errors. So, just something to consider. Really think about the best location for the scales, and make your life difficult once in mounting them. But do what's necessary to get them in the optimum place with the optimum guarding, and you'll be rewarded. I will sometime show you my manual Bridgeport scale locations, which are relatively insane, but very effective because they're mounted inside the machine. I realize in talking about with my digitals being mounted inside the machine, there's no way I'm ever going to show you how this is done, because I'm not going to disassemble this just to show you where these scales are. But the cross slide scales is actually down inside the machine about here, and the reed head rides the nut mount inside the Bridgeport, and then the scale is mounted to the actual knee. And as you can see, the cables exiting out the bottom there of the reed head of the x-axis scale is also sitting up inside on the saddle itself. So those two cables are the only thing that's exposed of the scales that are inside this machine. And then here you can see the z-axis. The z-axis, the head rides this. The scale is mounted right here, and that works extremely well. Very handy having a high resolution digital readout on the Z. I have some hydraulic motor bodies that I designed that require very precise bore depths within tenths because of the leakage effects of matching the lengths to the rotors. So there's an actual need for very, very precise depth control, and sometime I'll show the video on making those. Here's the location of my digital scale in my Bridgeport. As you can see, it's mounted underneath inside the table, and although that's an extremely difficult place to put it, it's bulletproof. The saddle of the Bridgeport, you can see here we just got some strips bolted on. Black Max is holding the Loctite Black Max 380 is holding on this same material, the neoprene waist stock, to there. And up here I've made a bar that actually sits on the dovetail with just that neoprene stock Black Maxed to the plate, and then it just hangs down smooth and mounts up and glues up underneath the onto the top edge of this saddle with Black Max also. Here's the aluminum rail that I made to hold the back edge up against the headstock. And you notice here I made took an end mill, made a slot, and then sawed through so that I could actually do the dovetail in one piece and just temporarily deform this aluminum out of the way so it could actually hook over, and then there's a bolt right underneath here that actually clamps it. I just keep it snug and actually clamp it rigid, but lets it get back on there without having a removable piece for the dovetail. So that holds the one end, and then you'll see that's the bar that bolts on that, and then this is the bar that bolts up here with the flatheads on this edge of the carriage, and it's the exact same length as the carriage. And then the gray stuff here is the gasket stuff that I showed you before. The ultra black is on underneath these also. Just wanted to show here that the Black Max 380 Loctite glue really gets a good hold on the neoprene. I'll show you the prep procedure that I use here. But what happens is the synthetic coolant gets in and actually starts to attack the actual rubber material itself, and that's what peels away here. You can see the actual original rubber that was glued on with the Black Max is still connected there. To get an optimum bond of the neoprene diaphragm stock to whatever you're bonding it to, I get two coarse grit flap wheels. I keep one for rubber, one for steel. I keep this separate because once you use it on steel, it loses its real crispy, sharp bite that once it's had to work that hard on steel. By keeping one for rubber, it really cuts nice and clean and stays that way. Also, you want to keep these very clean of any oil or any contamination on here that would give any kind of oily substance on the surface to keep the Loctite 380 from bonding well. So I just use these real slow speed on a flexible shaft. What we're after is a real coarse scratch finish like that's virgin, that the Black Max will get a good bite on. Now we have our prepped neoprene where we've scuffed this skin off of it, and our scuffed up steel, and now we're going to use our 380 Black Max toughened adhesive. Very good stuff. And we're going to put a layer on here. You definitely want to put it on the steel, not on the rubber. The rubber will make this stuff kick and cure before you want it to. And actually, the steel can be problematic if we don't get it on soon enough. So get enough on there that we can squirm it around a little bit. And it can be a battle to keep this stuff from. Sometimes you can just have it start to cure right on the part. Now the key here is to squirm it around and get it to form a nice even layer everywhere. Don't just, there we go, and get it in place. There we go. Once you got it in place, you got to be careful because it'll grab. Once you've got that, then press down and hold. It's not like this has to seal completely, hermetically. It's just that it keeps it from squirming as the rubber gets attacked from the coolant gradually. Once that gets a bite, I usually let it wipe off the edges with some alcohol. Get the loose, or uncured, I should say, not loose, but the uncured adhesive off the edges. Run down the crease here where can form a fillet, and wipe that off. Then we just take a number 11 X-Acto blade, find our hole, and then it's really easy to just go around and follow the hole edge and go around and cut this off. Cut the holes out. Find a hole, get in place, and just follow the hole. Do that to all the holes, and we'll do that to all the edges of all the pieces, and we'll assemble. This right here on the end is a place for the peel to start, and if I know from experience, if I don't mechanically hold this, this will eventually start unraveling from this location right here. It will just start giving. So just like 25 thousandths brass shim stock, fold over a piece, make a little channel out of it that goes on here and fits like that, and then I'll put a little Black Max on there, and then I'll crimp this shut with a pair of vice grips on each end. And then what this does is it mechanically holds that so that tear can't start there and just progress down the whole length. We'll degrease this here where the crimp's going to go on, clean underneath also. We'll rinse out the little channel that we made. Get that dried out. There we are. We got some in there now. Get that on. Locate it out to the edge so that it actually grabs out where the edge starts. Light grab with the pliers, push on and crimp so that that's mechanically held. Now it's got a good tight grip there on that mechanically. And that's not going to peel off. So when this gets tugged down here, it's fighting the brass, not just the glue bond. Now we're getting ready to put these on. We're just degreasing where the rails are going to hold on. I do this more for anti-corrosion purposes than I do for actual sealing concerns. I'm just trying to make it such that we don't get any major corrosion issues going on between these parts. So just put a nice thin layer of the ultra black on here. When the strip gets put on, we put a layer of CMD extreme pressure lube on the strip, and the stainless steel cover actually presses down against that and forms a basically watertight seal over that, wiping off the excess material, and then we're putting the solid riser block back on like you saw in the other video. So I hope this has sparked some ideas about getting some neoprene stock, diaphragm stock to use to guard your machines, using Black Max 380 to bond this stuff wherever it's needed. It's a quick and dirty way to get guarding on. It's very effective and can really improve the life of your machines. So just look around your machines for places where this could keep chips off the ways, keep dirt out, keep coolant from mixing with your whey oil, things like that. It's not always as easy as this. HLVH is kind of an easy candidate for this, the way the bed system works. So I understand it's not as easy to do everywhere, but give it some thought. I think you'll find places where this will be valuable. I hope you found this interesting, informative, and if so, please subscribe, tell your friends, share, and I'll be back.